Hello friends, today we are going to start our new topic, heat and temperature. In this lecture, we will study what is heat and how it can cause the rise or fall in temperature of an object. We will also study one of the effects of heat on an object, that is thermal expansion in one direction. That is how the length of an object changes due to rise or fall in the temperature of the object. After that, we will study about calorimetry and the concept of latent heat with the help of some examples. So let's begin. Let us first talk about temperature. Definition: temperature is a relative measure or indication of hotness or coldness. An object that has a higher temperature than another object is said to be hotter, and vice versa. That is, if an object has lower temperature than another one, then it is said to be colder than that object. The SI unit of temperature is Kelvin, which is denoted by capital K. Another unit which is commonly used for temperature is degree Celsius, which is denoted by this symbol. These two units are related to each other by the equation temperature in Kelvin is equal to temperature in degree Celsius plus 273.15. This is the conversion unit for temperature in degree Celsius to Kelvin. Now there is a note over here, that is hot and cold or higher temperature or lower temperature are relative terms like tall and short. That is, consider an object having temperature 270 Kelvin and another object having temperature 170 Kelvin. Now, just by looking at the number or the magnitude of the temperature of these two objects, we can't say that any of these objects is hotter or colder. But if we compare these values with each other, we can say that this object is hotter than this one. That is, the hotness or coldness of an object is decided after comparing it with some other object. Now let us talk about measurement of temperature. A measure of temperature is obtained using a thermometer. Now many physical properties of material changes sufficiently with temperature. Some of properties are used as the basis for constructing a thermometer. The commonly used property is the variation of the volume of a liquid like mercury or alcohol with temperature. This is a diagram of a typical thermometer. It is filled with mercury at its bottom. Now, as the temperature rises or lowers, the volume of this mercury also changes. With the increase in temperature, the volume of mercury also increases and it starts rising up in this tube of the thermometer. Now, these scales which are printed on these tubes of the thermometer are calibrated so as to give a measure of temperature according to the volume of the mercury or its height in this tube. So the variation of the volume of mercury as per the variation in temperature is the basic principle behind the working of thermometer. Now let us proceed further and talk about heat. Definition: heat is the form of energy transferred, which is denoted by Q, between two or more systems or a system and its surroundings by virtue of temperature difference to obtain a thermal equilibrium. Now, a thermal equilibrium is the condition in which the temperature between the two systems or the system and its surrounding becomes equal. So, if there are two objects, the first one has higher temperature than the second one, and then if we connect these two objects, then there is transfer of energy, which is nothing but heat, between two objects from the object having higher temperature to the object having lower temperature. And this flow will continue until both the objects will have the same temperature. That is, both the objects will become in the thermal equilibrium. Now, such energy transfer can occur in three ways, that is radiation, conduction and convection. Now in radiation, the heat energy is transferred through the space between two objects. That is, no physical contact between two objects or a system of objects is required for this type of energy transfer. And it is the radiation only by which the heat energy from the sun reaches to earth through the space in between them. The second form of energy transfer is conduction. In this process, the object is brought contact with the source of heat. The point just at the contact with the source of energy starts getting hotter due to continuous receiving of the heat energy from the source, and this heat starts flowing to the other parts of the object due to the temperature difference between them with the help of internal vibration of the particles of the object. In this way, gradually the whole object becomes hotter. And the third form of energy transfer is convection. This form of energy transfer is mostly seen for fluids like water, air, or any other gas. Take this example of water being heated up in a vessel. The water at the bottom of this vessel starts heating up and its temperature rises. Due to the rise in temperature, the density of the water over here becomes lower than the density of water at other parts of this vessel. So water at these points starts moving up due to the difference in density, and the water at top portion of this vessel starts coming down because of having higher density than the water at the bottom. So a cycle gets started, and in this way the whole water in the vessel gets heated. Now these were the three ways of energy transfer due to the temperature difference between two objects. Now the SI unit of heat energy transferred is expressed in joule, and another unit of heat energy transferred is calorie, which is the amount of energy required or transferred to raise the temperature of 1 gram of pure liquid water by 1 degree Celsius, provided the water temperature is higher than the freezing point, that is 0 degree Celsius, and lower than the boiling point, that is 100 degree Celsius. That is, 1 calorie is equal to the amount of energy transferred to raise the temperature of 1 gram of water, pure water, by 1 degree Celsius. So these were some basic things regarding temperature and heat. Now let us talk about some effects of heat, that is thermal expansion in one dimension. Now we have already studied that many physical properties of a material changes as the temperature changes. One of these properties is its dimension. So a change in the temperature of a body causes change in its dimensions. The change in the dimensions of a body due to the change in its temperature is known as thermal expansion. And the expansion in the length of a material due to the change in its temperature is known as linear expansion. That is, if the length of an object increases as there is a rise in temperature, then this is known as linear expansion. Now let us calculate the amount of linear expansion on an object due to some change in temperature. So consider an object in the form of a long rod. Now as the temperature of this rod increases by an amount delta T, the length of this object will also get increased by an amount delta L. Now the fractional change in length, that is delta L by L, is directly proportional to the change in the temperature, that is delta T. So delta L upon L is directly proportional to the change in temperature, or delta L by L is equal to alpha delta T, or the change in length is equal to L alpha delta T. Here alpha is the constant of proportionality, which is known as coefficient of linear expansion or linear coefficientivity, and it is a characteristic property of a particular material. Now if we denote the initial length of the rod by L1, and the final length after the expansion as L2. Then the change in length is equal to L2 minus L1, which is equal to the initial length, that is L1 alpha delta T, or the final length L2 will become equal to L1 plus L1 alpha delta T, which is equal to L1 1 plus alpha delta T. So this is the formula for calculating the final length of an object after its expansion in one dimension due to an increase in temperature by delta T. Let us understand this concept more with the help of an example. An aluminum rod has a length of exactly 1 meter at 300 Kelvin. How much longer will it become when placed in a 400 degrees Celsius oven? Take linear expansivity for aluminum equals 23 into 10 to the power minus 6 per degree Celsius, and the conversion unit equals temperature in Kelvin equals 273 plus temperature in degree Celsius. So let us solve this question. Let us donate the initial length of the rod as L1 equals 1 meter and the initial temperature T1 equals 300 Kelvin, which is equal to 300 minus 273 equals 27 degrees Celsius. So T1 equals 27 degrees Celsius and the temperature in the oven equals 400 degrees Celsius, which gives us the temperature difference T2 minus T1 equals delta T equals 400 minus 27 degrees Celsius, which is equal to 373 degrees Celsius. Now we have the formula L2 equals L1 1 plus alpha delta T, which is equal to L1 equals 1 meter 1 plus alpha, which is equal to 23 into 10 to the power minus 6 into delta T, which is equal to 373, which is equal to 1 plus 8.58 into 10 to the power minus 3 meter. Now since this change is very small, let us convert it into millimeter by multiplying it with 1000. That is L2 equals 1 plus 8.58 into 10 to the power minus 3 into 10 to the power 3, which is equal to 1008.58 millimeter. So this will be the final length of the aluminum rod when placed in an oven of 400 degrees Celsius. Now let us proceed further and talk about calorimetry. Calorimetry is nothing but the measurement of heat or heat energy transferred. When there is a difference in temperature of two or more bodies or systems, or a system and its surroundings, then transfer of heat energy takes place. The heat lost by the part at higher temperature is equal to the heat gained by the part at the lower temperature, and this is in accordance with the conservation of energy. Now, when a body at higher temperature is brought in contact with another body at lower temperature, the heat lost by the hot body is equal to the heat gained by the colder body, provided the system is isolated. Now, an isolated system means there is no exchange of heat takes place between the system and its surroundings. That is, if there is an object having some temperature T, then this system is said to be isolated if there is no exchange of heat energy between this object and its surrounding. That is, the temperature of this object will remain constant because there is no transfer of heat energy. Now, a device in which heat measurement can be done is called as calorimeter, which works on the principle heat gained is equal to the heat lost. Here, this is a typical diagram of calorimeter. It is basically a type of container in which all the walls of it are insulated. That is, there is no transfer of heat energy between the surrounding and the liquid in it. It also contains a thermometer and a stirrer which is used to continuously stir the water inside this calorimeter. Now, whenever an object is dipped or placed inside this calorimeter, then there is a transfer of heat energy between the object and the water. If the object is at higher temperature than this water, then transfer of heat energy takes place from the object to this water. Or if the object is at lower temperature than this water, then transfer of energy will take place from water to the object. The temperature of this water will either fall or rise, which is recorded by this thermometer. By knowing the initial and final temperature of the water, the heat energy lost or gained by the water will be calculated, and that heat energy will be equal to the heat energy transferred between the object and the water. In this way, the measurement of heat transfer will be done using this calorimeter. Now let us proceed further and talk about latent heat. Before talking about latent heat, let us discuss what is change of state. Now, there are three normal states of matter, that are solid, liquid and gas. A transition from one of these states to another is known as change of state. And the two common changes of states are solid to liquid, which is known as melting. For example, an ice which is in solid states changes to liquid, and this process is known as melting. And the second one is that liquid to gas, which is known as vaporization. For example, the change of liquid water to gas or steam is known as vaporization. Now, during the change of state of matter, say solid to liquid, the temperature remains constant during the whole process. That is, the temperature remains constant until the entire amount of solid changes to liquid in the process of melting, because the heat supplied is being utilized in changing the state from solid to liquid in the process of melting. Let us understand this with the help of this graph. Here we have plotted the temperature versus heat added graph for water. Now let us assume the water is at minus 75 degrees Celsius in the initial stage. Now at this temperature, the water is in the form of ice, or we can say in the form of solid. Now as the heat is added, the temperature of the ice will increase. It will increase continuously until the freezing point of water will reach, that is the 0 degree Celsius, this point. Now we know that 0 degree Celsius is the freezing or the melting point of water. That is, the ice will start melting into liquid. Now here we see that the line is straight, that is, heat is continuously being added, but the temperature of the water or ice is still constant, that is 0 degree Celsius. It is because the heat added in this region is being utilized for changing the state from solid to liquid, that is from ice to liquid water. Now as soon as the whole ice is converted into liquid, the temperature will be no more constant, that is, it starts increasing. It will increase continuously up to the boiling point of water, that is 100 degrees Celsius. At this point, heat will be continuously added, but the temperature will remain constant, that is 100 degrees Celsius. At this point, the liquid or the water will start converting into gas. As soon as the whole water is converted into gas, the temperature will again start increasing. So this is the concept of change of state. Now let us talk about latent heat or its definition. The amount of heat per unit mass transferred or required during the change of state of a substance is the latent heat of the substance for the process. That is, if there is a change of state from solid to liquid, that is the process of melting, then the latent heat for melting is the heat energy required per unit mass of this substance to change this substance from solid to liquid. Now, if a mass m of a substance undergoes a change from one state to another, then the quantity of heat required, Q, is given by Q equals mass of the substance into L, where L is the latent heat and is a characteristic of the substance, and the SI unit of latent heat is joule per kg. Now, the latent heat for a solid liquid state change is known as latent heat of fusion, which is denoted by LF, and the latent heat for liquid gas state change is known as latent heat of vaporization and is denoted by LV. Now let us take an example. Why burn from steam is more serious than that from boiling water? It is because the latent heat of vaporization for water equal to 22.6 into 10 to the power 5 joule per kg. That is, at the boiling point of water, the steam or the gaseous form of water contains this much amount of more energy than the boiling water, and this extra energy is responsible for more serious burn than that from boiling water. So this is all for today's lecture. I hope you understand all the concepts. Thanks for watching and have a nice day.